without further ado, so that was a really insightful presentation. It was filled with data and number. So for my colleagues present here who might not know the importance of steel and why we decided it as the theme of our panel discussion, I'll just quickly go through some of the more interesting facts about steel. So as we know, steel is one of the most used materials around the world, and also we as metallurgists and material scientists, we study steel in depth. So 2.5% of entire India's GDP comes only from the steel industry. I personally think that is a really insightful data, and that can motivate people to work for this sector. But interestingly, 28% of the entire steel produced in India come from the induction furnace, which is often a very less talked about field here in the academic area. So we were also talk more about the primary steel making route, mostly consisting of the blast furnace and the basic oxygen furnaces, and induction furnace was not talked about that much. So this discussion would start those discussions around induction furnaces and innovations around those. So we also know that India's per capita steel consumption is very low at 75 kgs compared to the world average of 225 kgs. But India currently holds a major majority of 45% share of total steel produced globally by induction furnaces. So we can conclude that India is a leader when it comes to steel making by induction furnaces, and hence this panel discussion. And just to bring about an interesting figure, roughly the market amounts to $27 billion. So some reasons for the rise in use of induction furnace in steel making in India could be accounted to the low grade of coal and ore, which is not suitable for blast furnaces, and also the increase in availability of scrap as mentioned by Saijal. So coming back to another interesting fact, although the induction furnace steel market in India is a very fragmented market, as we can see, but the equipment manufacturing market is a well-organized market with three major players, namely Electrothumb, Megathumb and Inductothumb, sharing almost 94% of the market. This brings about a very interesting concept that we should push more innovation and research in this field, because since this is a well-organized market where we can hold a major majority and advantage. So with increasing competition and climate crisis, research and innovation is the only way ahead. And this panel discussion aims to talk about innovation around induction furnace steel making and its scope with the context of future in Indian steel market. Without further ado, I would like to introduce our esteemed panelists for the panel discussion. First, we have with us Vishva Bandhu sir, who is the Chief of Commercial of Stainless Steel Division at Mukund Limited. He holds a B.Tech degree in metallurgy from IIT Bombay, so he's also our esteemed alum, and he also has a diploma in management studies from University of Bombay. He has over a decade of experience in steel. He has worked in the steel melting shop and was also head of it for about 4 years. He was also assigned to Hospet plant for smoothing commission of the Hospet SMS. He also served as the Deputy Chief Executive of MSMPL since 2012. He is currently heading the Stainless Steel Business Division. We welcome you to the stage, sir, and I request Sudhvi to welcome you to the stage. We have with us Vishva Bandhu sir, who is a Senior Deputy Director at National Institute of Secondary Steel Technology. He has completed his M.Tech in Metallurgical Engineering from IIT Kanpur. His areas of expertise include iron making by blast furnace to stainless steel making. He has conducted detailed research energy audits on behalf of DE in steel plants and holds enormous knowledge in the same field. I invite Mr. Vishwa Bandhu sir to the stage and request Siddhi to Next panelist we have with us Mr. Nitin Kabra, who is the director of Bhagyalakshmi Rolling Mill Private Limited. Bhagyalakshmi Rolling Mill Private Limited is a 18 years old company incorporated on 2004. Their main line of business is manufacturing of basic metals. It is one of the largest mill in Maharashtra with all the state-of-the-art technologies. I heartily welcome sir to the stage and request Siddhi to welcome. Next we have with us Professor Asim Tewari, who graduated with a BTech degree from IIT Kanpur and has a PhD from Georgia Institute of Technology, USA in Material Science and Engineering Department. After his doctorate, he was briefly with National Aerospace Laboratories. Subsequently, he joined IIT Kanpur where he served as assistant professor for over 3 years. He is currently professor in the Department of Mechanical Engineering and a faculty member at the Center of Machine Intelligence and Data Science at Indian Institute of Technology, Bombay. His area of research is in the mathematical model of microstructure mechanics and applied machine learning. He has extensively published in peer-reviewed journals and has been awarded with many international patents. I welcome sir to the stage and request Siddhi to welcome.
It's a very unique, I would say, panel discussion where we are looking at a specific topic which, when I was requested, I readily jumped upon, only to later realize that this IF is not interfacial steel, but this induction furnace. But nonetheless, it's a very interesting topic, and I have been very closely associated with a lot of steel manufacturing research, and I feel this is a very august panel to actually talk about this aspect. So the way I'm looking at it is that I would request each panelist to have an opening remark for about 5 to 10 minutes, maybe 7 minutes, and then I will have specific things which I would ask, and maybe to individuals and also to anyone else who feels that this is a topic of their interest, and with maybe a couple of rounds or 2-3 rounds of that, then we will make it open to the audience for them to ask questions. So may I please request Ms. Parse? Does it work?
Good evening to all. And it is a great honor to be here at IIT Bombay, my old institute where I passed out 40 years ago from the Department of Metallurgy. I feel very nostalgic when I come here back again. So I worked in the steel industry since then, for the last 40 years. I have been with a company called Mukund Limited, which is basically an electric arc furnace company. We have been manufacturing steel since then. I want to start this topic by saying that we have a very big problem on hand, that we have a lot of scrap availability issue in the steel industry, in both induction as well as the arc furnace. India imports a lot of scrap. We also import, our company also imports a lot of scrap. But now with the government of India coming out with a new scrappage policy, I hope this problem will be behind us. We expect that area like Alang, which was known to be a ship-breaking area where a lot of scrap was available will now become a new hub for automobile scrap. With this availability of scrap, I hope and I'm sure that a lot of investments will come into steel industry, both in electric arc as well as induction. However, I don't know when it is going to happen, but we are looking forward to it. Now coming back to the topic of steel, it is necessary that we spoke about it in the earlier panel discussions about sustainability. India has already given their commitment for reducing the carbon dioxide emissions. So having scrap as recycling will help in achieving both these objectives. Melting the scrap is in two possibilities. One is induction furnace, one is electric arc furnace. I have not much experience in induction furnaces, but I know for sure that induction furnaces have a very great advantage that they are low in investment, low in OPEX, but they are low in productivity as well as they are higher in energy consumption. As against that, electric arc furnace can be very productive. Our electric arc furnace, which is a 40-ton furnace, used to produce 19 heats a day when we used to make carbon steel. And very low energy consumption, very low cost, but the investments were very high. So there we have a different aspect of investment versus what is required. Induction furnaces are small furnaces where generally a lot of manual work is done. Electric arc furnace can be optimized, can be automated quite a lot. You can have possibilities of additional source of energy such as oxy-fuel burners, etc. You can have huge amounts of water-cooled panels, water-cooled roofs. So the maintenance also goes down quite substantially. And the uptime of the furnaces also increases quite a lot. Since 1998, our company has stopped making alloy steel, carbon steel in this plant at Talwe. We have shifted our plant, alloy steel, to our plant in Hospet. Now we produce only stainless steel in this Talwe plant. But our major source of raw material is stainless steel scrap, which is imported. So I hope with this new scrappage policy, the availability of scrap in India will increase. It will help the steel industry in a big way. Thank you.
Good evening, everyone. First of all, I would like to thank Metallurgy Department for inviting us and giving us a platform to represent induction furnace, which is a very unknown area for the academy and most of the people in the steel cycle. I represent industry which is completely doing what the earlier session was talking about, sustainability. We collect scrap. While collecting scrap, we see that we transport the scrap with the maximum density possible so that the fuel consumption in the transportation of the scrap is also taken care of. While bringing that scrap into the premises, we do all kind of segregation with the sizing, with the chemistry, with the uses, and certain reusable material or the components are sold again. And after doing all the processing on the scrap, we use it in the induction furnace. And to surprise you more, we do not throw away anything of the byproducts generating out of the induction furnace route. Whatever slag is generated, we convert it into sand, which can be replaced, which is replacing river sand in the construction of various, or in the construction industry, in concrete and mortar. Even the fumes which are coming out of the furnaces while melting the scrap, we capture that, and now we are putting up a process to recover zinc out of the fumes which are being generated during the melting process. Water cycle is completely zero drain. So when you talk about sustainability, it's not about just projecting things, it's about doing it every day. And that's what most of the induction furnace people are doing. They were earlier looked as a kabaddi or that kind of view, but I tell you, my industry is already on Industry 4.0. It's already on. Since last 1 year, we have implemented Industry 4.0 completely. So the kind of technology we are using, cloud computing, data processing, everything is there. Traceability, when you say traceability, it's quite easy for induction furnaces people to keep their traceability record of the finished product which they make. So this is not an era where induction furnace can be looked as in some 18th century technology. Rather, when we travel abroad, we say with pride that this is a technology which India is offering to international community when recycling comes into picture. So, induction furnace, again, one more thing I would like the August gathering to correct their terminology. I will say this is a disruptive terminology which I am introducing now. There's no thing called primary or secondary, okay? So there is an iron ore route. In iron ore route, you have two different processes. One is through blast furnace, another is through DRI plus induction furnace, and then there is the recycling route. So there is nothing called primary or secondary. So we belong to recycling route, and a couple of my colleagues belong to even iron ore route through in rotary kiln, DRI manufacturing and steel making. There are different routes having certain advantage, certain disadvantage. Induction furnace can be there in sponge iron route as well as in recycling route. Similarly, electric arc furnace can be present in both the routes. Worldwide, when you talk about recycling, most of the time they do it with electric arc furnaces. And they have developed that technology over the last almost 50, 60, 70 years. They have not invested. Normally the research has been done in the West. So they were not interested in induction furnace because those days the safety norms and all other things were quite stringent. And it proved to be more easier to do it in arc furnace compared to induction furnace. So they have not invested technologically on the induction furnaces. So the responsibility of developing induction furnace route as an alternative recycling route falls on institute like IIT Bombay, all other academia. We extend all support, all platforms to interact and understand how the operations, the economics of the induction furnace works. And with that, I think I'll stop over here. We'll take on the questions. Thank you.
A very good afternoon to all of you, students. And you will be playing your role in making and shaping of India's future. And I should not restrict to India, rather you are IITians and that too from Bombay. So you will be making and shaping the future of the whole world. Because you see, most of the IITians, they are sitting at the very high positions of world-renowned companies. So a very good afternoon. And before we come to the specifics of this theme, let me introduce you that this iron and steel sector, as Steelmint presented that the steel production is more than 1900 million tons, that is on record per year. India's contribution is something around 120 million tons. Okay, no issue. But I am throwing you a challenge from here that unfortunately the steel is produced in such a large quantity, 1900 million tons, more than that. But we could not find a process, we could not develop a process which can make the steel directly from iron ore in a single step. Scientists and engineers, they are breaking their head day and night to develop such a process which can make the steel from iron ore in a single step. So that is the challenge to you, young minds. So today we are manufacturing steel in 2 steps. Everywhere you see, whether it is a major steel plant, integrated steel plant, small steel plant, whatever. We are making iron first from iron ore, that is the natural resource. We are making iron first, either by the blast furnace route or by the DRI route. Of course, there are another, in the DRI route, we have coal-based, gas-based, synthetic gas-based. But first we have to convert iron ore into iron. And then that iron we are converting into steel. So this is one of the biggest challenge which is facing the Indian steel industry. Now coming to this primary route, secondary route and all that, the Ministry of Steel has done away with all these terminologies. Primary steel making route and secondary steel making route. Now all steel they are same if the composition and the properties they are matching. For example, mild steel which you see which is used extensively for construction purpose, IS 1786. Whether it is produced by integrated steel plants, whether it is produced by arc furnace, whether it is produced by induction furnace route, if it meets the specific requirements as specified in the Bureau of Indian Standards specifications, then it means it can be used for any application. It is what it meant for. So as far as the integrated steel plant, mini steel plant, they are concerned, this theme is on arc furnace and induction furnace. And let me tell you that they are not, people think that they are competitors to each other. No, certainly not. They are not competitors to each other. Arc furnace is for producing specific grades of the steel, high value added quality steels. If someone is producing mild steel from arc furnace, he is not doing justice with his plant. Not at all. So the arc furnace route is specifically for making special steels like Mukund. They are making stainless steels. I have visited their Hospet plant. They are making all kinds of high value added steels, which are sold at a price of maybe 1 lakh rupees per ton, 80,000 rupees per ton. While induction furnace route, they are specifically meant for producing mild steels, which is extensively used in construction purpose. Of course, some of the induction furnace producers, they have also developed themselves to produce some of the value added steels. But then they have added some balancing equipments, some refining capacities, they have added to that, because high value added steels demand some quality characteristics of the steels, something very high in quality, not only phosphorus, not only sulfur, like other metallurgical properties, like they must have some structure demanded by the customer, as demanded by the application where the steel will be used. So this is all, and the advantage of the induction furnace is that they can be set up in small capital. For example, if I want to set up a 20-ton induction furnace, I can set up at a cost of let us say 50 crores. If I want to club it with the rolling mill also, I can set up that rolling with the rolling mill. I can set up at 70 crores, 80 crores. I can have a steel plant with steel making as well as rolling also. While if you go for the integrated steel plant, you have to set up a minimum to minimum 1 million ton capacity. Even 1 million capacity is not enough for an integrated steel plant. You should start with a 3 million ton capacity. The economies of scale demands that. And to start with a 3 million ton plant, you need an investment of something around 25,000 crores as on date. $1 billion per million ton of steel. So each area is of different, either the scale is concerned or whether the quality of the steel you want to produce, that is concerned. The advantage with the induction furnace is that you can set up it at any place. Because I normally depend on the scrap, and scrap is normally locally available to some extent at least. So that is also a advantage with the induction furnace sector. So with these words, I give the mic to Mr. Tewari.
Thank you. Thank you very much for a high energy start for the talk. So essentially, why should the metallurgists just be, or IIT Bombay metallurgists be limited to, the world? You said they'll be guiding the world. So of course they're leading tech companies around the world. The metallurgists are doing that. But metallurgists may not know that actually steel, iron is not really a simple stuff. Iron is a star stuff. Iron is not made by our star. It has come from outer stars. So hydrogen and helium is all what sun can make. And steel, the iron, which is the main key thing, actually that comes from other stars. So we are essentially working on star stuff, truly speaking, literally. And thus we are not just limited to India, world, we are actually talking of the cosmos at large. So very great actually. Looking at the specific sector of induction furnaces and in steel, in India primarily they are used for scrap only. A very large is used for scrap, and there are of course obvious reasons. You very rightly pointed out that it's very easily possible for you to set it up at a lower cost. You don't have to transport scrap over long distances, so you could have locally distributed. So essentially it's a question of techno-economic aspect. You essentially have very large scales, then you may want to go for integrated steel plants. You have very high specialty, you may want to go for arc furnaces. Whereas if you're looking at scrap, then probably induction becomes the process of choice. So if you look at any industry, it is driven by basically three parameters. One is productivity, the other is quality, and the third is efficiency. Now this may sound a little alien to industrialists, so they understand the same three terms in a slightly different manner, which is faster, better, cheaper. So you are faster, you are making better, and you're making cheaper. So this is essentially the key drivers. But over the last decade or so, and more so now in the last few years, there are two other factors which have started playing a major role in this. Apart from these three internal economic parameters, the other two factors are the other two E's, the energy and the environment. And in the Indian context, the third E also starts playing a very major role, which is employment. So essentially this is something which really is where induction furnace based processing is at its best, because it's actually MSMEs, generates a lot of employment, and if properly used, and that's what we'll be discussing today, we can very efficiently have energy and environment impacts minimized. So with that, I would like to open up and ask the first question, that what role is government going to play, especially for instance you look at the Bureau of Energy Efficiency. Now Bureau of Energy Efficiency is essentially there to see what is the efficiency of energy consumption per unit ton of steel and things like that. But it really does not have that much legislative power, or it doesn't have it in a sense. It's more of an advisory body. So now, with moving forward, do you see that government can play a major role in the other two E's, energy and environment? And I will start with you to ask you, what role do you see government might play to improve the energy and environmental footprint of induction-based processing?
Yeah, it's a hot topic as on today, that we must focus on energy and the environment, and of course the employment also. See the BE, which is the organ of under Ministry of Power, Government of India. I'll correct you, sir, that it is not on an advisory role only. Now it has started, it has the legislative powers also, and okay, yes sir. See, because we have a global commitment, and recently in the last year Copenhagen summit, our Prime Minister committed that by 2070 we have to be carbon neutral. Everybody knows, I suppose. Earlier it was restricted up to 2030, and we were committed that we have to bring down the CO2 emission level by 45%. Base year was 2005. That means in the span of 25 years, from 2005 to 2030, in the span of 25 years, we have to bring down the CO2 emission level by 45%. So that's not a joke. So what now how the government works? Government gave this power to the Bureau of Energy Efficiency, that you look after that how we can curtail the CO2 emission by 45% in these 25 years. So what the BE has done is, BE has identified 11 major industries which are high energy consumption industries. Iron and steel industry is one of them, because iron and steel industry consumes huge quantity of energy. So what then we started working on it, and they identified 11 number of industries, and they then they started baseline studies in every sector of the industry in these 11 sectors. Iron and steel is also one. So once they got the data from the baseline study that how much energy is really consumed, they appointed certified energy accredited energy auditors for doing this baseline study. Now we did baseline studies also on behalf of BE and find the data that how much energy is consumed. Then based on that data, then BE gave the target that within 3 years you have to bring down the energy consumption by say 7%, 8%, 9% or something like that, based on the baseline data. Then we as a accredited energy auditor, I am a certified energy auditor under BE. So we also verified that parameters, the data, that yes, after 3 years how much they have achieved. Then on that data, which again becomes a baseline data, then again they set a target of 7%, 8% energy consumption level to be bring down. And that's why, and they have system of rewarding and punishment. If some industry is not able to achieve the desired energy consumption level, then they have to purchase energy certificates from the market. And if someone is able to achieve more than that, then they were awarded energy certificates, and they could trade them in the market. So that was the mechanism BE has implemented, and now we are seeing that energy consumption levels have gone down in at least in the steel industry, I know, to a significant level. But now, because of the stringent requirement of becoming 45% reduction, achieving 45% reduction by 2030, now it is becoming more stringent now, and now giving very tough targets now. So we are on that path, and we are achieving all those energy consumption figures which are really required. As far as the BE has classified up to a certain energy consumption level, and in induction furnace they are not coming under that, because induction furnace are small capacity furnaces, and they do not consume much amount of energy because they are consuming only electricity. And as far as the electricity is concerned, the energy consumption is quite low as compared to the integrated steel plant and big arc furnaces, which are consuming lot of quantity of the DRI and coal, coke in their manufacturing process. Some of the arc furnaces have come into it, but all primary producers, they fall under this BE for energy consumption. As far as the induction furnace is concerned, BE has not touched them till now. But time will come that induction furnace industry will also fall into that, because they are planning that we have to go deeper into it. So, as far as the power consumption or the energy consumption in DRI, in the induction furnace is concerned, they are very fortunate that those who are making steel by the scrap, melting of the scrap, there is not much of the energy consumption. It is only 550 or 600 kWh per ton. But if I are using DRI as a input material, then their electricity consumption goes up. Okay, maybe depending on what the percentage of DRI they are using, that may be 600, 650, 700, 750 also. And depending on how efficiently they work on it. But here we have to bring the concept of the green energy or the RE that may be at a later stage. So this is the status of the industry for the induction furnace as of now. Yes, sir.
Well, thank you for elaborating the energy aspect. So one of the key aspects about induction furnace is that unless the raw material is well segregated and compacted, the induction process itself, the physics of it makes it very inefficient actually. So if you have a very loosely bond scrap, the scrap is not highly dense, you essentially will have a very low induction efficiency. And induction efficiencies could easily be 60%, 50%, and sometimes even lower than that. So if you have a lot of voids in the process of charging, and that essentially also means that you have a possibility of an ecosystem where there could be a segregator which could essentially be segregating scrap, there could be someone who could be compacting scrap and making blocks. And that is one thing which India has been importing a lot, and maybe I would like to ask you as to how do you see the scrap import or the secondary, I would say, ecosystem, not the secondary steel making of course, the secondary ecosystem of people who are essentially in the entire recycling of scrap, starting from taking, so especially for instance the automotive policies in India have changed. We will be producing far more scrap, and this may really spin more industries which may be looking at segregations. You don't want to mix different kinds of steel together, you want to compact them, chop them, and that will make the induction process far more efficient as well. So how do you see that happening, and do you really see anything in that direction?
Yeah, I'll just come to that in a minute, but before that, the energy part of it, I just want to just say one thing. In our company, way back in 1987, we installed scrap preheater. We used to preheat the scrap to about 600 degrees centigrade and save energy. So that was the energy efficiency that was brought in. Secondly, about environment. Those days we installed a baghouse. Our furnace is next to the city of Mumbai, but no gases, no dust coming out of the plant, not allowed. We installed baghouse then. So these are the two things that we did then, which now it has become compulsory to do. You cannot work without this. Coming back to the scrap part of it, I visited a lot of scrap yards in my earlier days, and where automobile scrap crushing is going on, and a lot of things that we used to tell them. Number one, remove the engine first. The engine is all cast iron. They were not doing it, so we used to tell them remove the engine. Then remove the seats, which is all rubber. Remove the tires, which is all rubber. Once they do that properly, then we used to have better quality scrap. Even that scrap, when we used to bring that in those days, I'm talking now 90s, in those days when we used to bring the scrap to our country, we used to segregate it ourselves into small pieces, cast iron pieces, and we used to separate them so that we don't get mixed up when you melt. The shredded scrap was there. The most popular scrap was shredded scrap. The shredding machines, huge shredding machines. The automobile scrap, the main scrap, the body is very good quality scrap, but the rest is alloy steel. And the engine is cast iron. So we used to be you have to be very careful in all that, and you have to educate the scrap yard to segregate this properly. Another thing that we used to do is baling the scrap, baling it into 1 feet by 1 feet, 2 feet by 2 feet, so that it becomes easy and dense to melt the scrap. Density of scrap is very important because every time you swing out the roof of the furnace, you lose energy. So it used to have maximum 2 charges in a heat allowed. If you have to put the third charge, which means you have lost energy. This is what we did in scrap working and we used to do. Now it has become now regular practice. Now there are a lot of scrap yards are doing this very regularly. But when the scrap yard industry was new, this was what was taught to them to get these things done that way.
I would like to answer your first question, that was role of Bureau of Energy Efficiency vis-a-vis in energy and environment. See, when we do businesses, businesses are not driven by the policies. Businesses are driven by the profits. Somebody like it or don't like it, that is the rule of the business. So, saving energy is primary role of a manufacturer to survive. To give you an example, and as Vishwa sir said, that they have not touched induction furnace as of now, right? I take that as a compliment, because when they must have studied, they have gone through the energy consumption pattern of various steel making routes, and they have found that the induction furnaces are already on the mark. So there is a little possibility for them to improve on us. In 2010-11, certain people experimented. See how finished products are made. Let's understand first. Either it is recycling or iron ore route. You first, if you are on iron ore route, you first make iron and then make steel, and then you cast it, make into semi-finished billets. Earlier it used to be cooled, then reheat and roll. You will be shocked to know in this reheating process, per ton of steel, it consumes around 3,20,000 kilocalories per ton. Okay. Without any academia's intervention or support, the so-called induction furnace routes have eliminated this reheating process altogether. And approximately 40 million ton of steel in last 10 years has been produced without any reheating process requirement. So 40 million tons into 3,20,000 kilocalories per ton. So you can see the quantum of energy being saved by the induction furnace. And let me tell you again, no academia has came forward to support this. Apart from this, when you say regulation, and in the earlier forum, people were talking about sustainability. We, who are the champion of sustainability when the steel recycling comes into picture, have been given a secondary view when government comes as a customer. So railways, national highways, if they want to use rebars, they say, they specify in the tender, and this is the, I will say, hypocrisy which government plays on their side. They specify in their tenders that steel made out of iron ore route only. So you are discouraging recycling on the policy side and want the bureaus or the inspectors to come to the factory so that you can serve the interest of few chosen few. So if you want to come and assist us, we are open. We in fact want institutes, academia and the bureaus to come and guide us to further reduce the energy consumption. That's not no way we will resist that. But see, if the bureau is thinking that induction will not need to be touched today, it says a lot. Though it has been represented as they are small, and I heard quite a few times that the induction furnace has a capacity limitation. I'll tell you, 2 years down the line, by 24, you will find many induction furnaces having capacity of 1 million ton and more. The place I belong to produces 5 million ton of steel a year, all rebar, produced by around 5 or 6 players. We are already 0.7 million ton and so. So induction furnace doesn't have any capacity limitation. Yes, capacity limitation comes from availability of the raw material, which government has already addressed with the circular economy thought process and scrap recycling policy. So whatever Steel Mint has presented, that the contribution of the induction furnace will go down over next 8 years. I have a dispute there. And time will tell. I can assure you the contribution will go up because of the efficiency and the quality commitment given by the induction furnace route. Thank you.
So actually the major role of today's panel discussion is to bring three parties together. One is academia with industry and government. Certainly government is not being represented here right now, but we'll make sure that we do come in part, yeah, so auditor, but we'll certainly try and see. So I think this is more of a lectina which the government has had, and I exactly remember when you said this because I had been a part of many such discussions in the past where they have actually said that the rebars have to be coming from the other process rather than this. And I think this is something which can be addressed, and academia can certainly play a major role. But there's a much bigger role which academia can play. If you see here the young metallurgists sitting here and senior seasoned researchers, my colleagues, we essentially have a lot of specific aspects of technologies and I would say aspects which you can contribute, provided there is a more healthy two-way discussion between academia and industry, and we can essentially address the problems of industry. So you said no one came, but probably it was that we were waiting and no one came to us. So industry, and especially IIT Bombay, has been very, very, I would say, open and in interacting with industry. So we are really very much open. So all my colleagues would be very happy to have interactions with industry, especially the induction furnace industry. And one of the key aspects of induction furnace, for instance, is the ramming mass. If it becomes acidic, you essentially have a phosphorus issue. And that leads to quality aspects, and that really something which we can address, I feel, if provided we try to work towards it. So I feel there is a huge potential for induction furnace, in especially the recycling economy, and there are still many technological gaps, which I think we may have the solutions for, provided we work together. So with that, I would like to understand that one aspect of as you rightly said, the cast iron products being not segregated, leading to, alloys will have high phosphorus and the things which may come from there. But apart from that, the very basic technology of using acidic ramming mass, which essentially will make it much less possible for the phosphorus to be taken by the slag that easily. So that is still a challenge, which I don't see as a technological challenge only, it's a techno-commercial challenge, because we do have a solution. That solution is a little more expensive from what I understand. But that's where the applied research comes into play. So I'm sure that my colleagues here who work on aspects of slag designs, slag chemistry and aspects, they certainly could contribute to that. So with that reference, I wanted to understand, and anyone in the panel who thinks they are well aware of it, as to how do you see the rest of the world where they are using induction furnaces? How do you see the slag technologies, the ramming mass, going from acidity to neutral is being used? So is there something which we can learn, or is it something very specific to the Indian requirements, and we have to reinvent, or rather we have to invent our own technology for that?
Being induction furnace guy and the appropriate one to address this question. While recycling scrap, you do process in two stages. One is melting and second is secondary refining. And probably from here the secondary word came to the main forum. So basically induction furnaces were earlier used for the scrap recycling. So when you have a scrap, the problem of sulfur and phosphorus doesn't arise, because when you make the original product, you already control those elements. And we are just garbage in and garbage out kind of melting process. So those days it was not required to have or do any control or reduce phosphorus or sulfur. So earlier scheme of setup used to have induction furnace and casting process, either on the mold or a continuous caster. But as the sizes are going up, now scrap is being substituted by iron ore or DRI. So now there are problems of phosphorus coming into the picture. The first thing we need to understand, I'm not disputing on the BIS 1786. Okay, so don't listen from that perspective. But BIS 1786 also specify the strength parameters and elongation parameters, bend rebend parameters, which ductility parameters. If for the application of construction, those parameters are met, and in meeting those parameters, certain amount of phosphorus gone up, whether it is economical just to match the numbers which have been wrought centuries ago on a paper of BIS, whether we should invest and add more operation cost to reduce that cost. That is the first question. So here the academia can play a role. What is the right percentage? 0.055 is right? 0.075 is right? Or 0.045 is right? So there are various known grades of steel where certainly you may not be allowing 0.02 to reach. But this is a commercial product going to the construction. What are the detrimental effect of having a phosphorus maybe close to 0.06, 0.07? Seeing to it that we can use whatever resources we have within our country in the form of sponge iron. So first is to evaluate whether we really need to reduce the phosphorus. That is part one. Coming back to ramming mass, the original question. Ramming mass use, whether acidic or basic, is not driven by whether we could able to reduce phosphorus or not. Because in the melting, we are not doing the secondary metallurgy. It is not advisable because you cannot waste the time in doing the secondary metallurgy. You have to take it to some other equipment, LRF or whatever is there, and you continue with your melting in the main equipment. But my friend is already toying with the idea since last couple of months. In his factory, he has already using in one of his furnace basic ramming mass. The advantage it gives again is the economics. The sustainability of the ramming mass, or I will say the life of the ramming mass as an insulator in the furnace is around 40 hours, acidic ramming mass. By using this basic ramming mass or neutral ramming mass, it has been enhanced to almost 120 to 140 hours. So it is driven by economics of operations. Still, it is little costly than the acidic ramming mass, but we are finding out the ways to reduce that by increasing number of patchings and various other things. We are getting some power consumption reduction because of longer cycle or patch life, and this is again very at a nascent stage, and I'm sure in the next couple of years this neutral ramming mass will take the central stage. And again, it is driven by economics, not by any bureaucratic requirement. Thank you.
So, well, certainly, so as academia, we do work very closely with BIS, and my colleagues here in metallurgy as well as in civil, they work on aspects of rebars, and there is a big buzz about glass fiber composite rebars, which is, of course, which has its own challenges, of course. I don't want to talk about that. But I think it is important for us in the steel industry to work very closely together with academia to kind of go back and see that can we have the properties-driven standards rather than just composition-driven standards. And this is something certainly which we can take up. Coming back to the aspect of phosphorus in the furnaces, that's essentially coming garbage in, garbage out, as you rightly said. And that brings another very big area of research, which my colleagues here are working on, and that is the aspects of industrial IoT and industry 4.0, where you're able to track every aspect of your scrap. You have a RFID-based sensors, you know what scrap is of what bond, what is the origin, and every aspect about that. And this, I feel, may really be a very big driver in extracting that extra efficiency, which right now was just being lost because we were not able to keep track of the origin of scrap. And as you rightly said, that at your end you have been working very closely for that. But I think the next level of that would be where the Industry 4.0 will start playing a major role, and everything will be RFID. You could figure out what was the origin, what is the composition, and segregation problem, which is I think the biggest problem in phosphorus will go away. And you did mention Industry 4.0. So maybe I'll ask you as to what exactly is happening in Industry 4.0 in your organization.
See, there is one clause in any standard you take, even in BIS, to have a traceability of the product. So whatever finish I produce, I need to certify that the source material, the process parameters, the quality parameters are traceable. To get that at an industrial scale is manually, the way earlier people used to do with the forms and all, checklists, cumbersome and not a transparent one. So what we did, we started taking all the parameters of all the equipments which we have in the factory on the cloud. So the induction furnace, when the sequence starts, the first batch of melting starts, it records the parameters, it records the power consumption of that particular heat, it records the number of samples we took for the chemical analysis. We record those chemical analysis during the slag off and the final type off. All the parameters of the induction furnace, plus which ladder it has traveled, what are the gas purging we have done, the caster parameters, the cooling rate, the casting rate, and the temperatures, everything is recorded. While rolling, all the parameters of reduction, percentages, and the speeds, and the quenching process, everything is cloud. All the data are sent on a cloud. As you rightly said, various RFIDs, the sensors, the readers, even the process data, current, amperes, temperatures are all communicated to cloud. And all that information has been organized in such a way that if you ask or you go in my yard, take out a sample of a bar and ask me, and there are tags applied on each bundle. You take a sample, you do all the investigation on chemical and mechanical side, the tag which is printed, barcode tag which is printed gives the same result as that of what you get in the lab. So this complete integration we have done on Industry 4.0. Now we are toying with the idea of scrap analysis using phototechnology or the vision technology. So we are, while unloading scrap, we are taking a lot of pictures, we are building a big database, and we are interacting with various industrial supplier or IT industries to give us a solution so that while charging the scrap in the furnace, we should be able to evaluate what kind of scrap is being charged and what could be probable chemistry of that charge. So on that side we are working on. So, and there are many other aspects which we are working on with the Industry 4.0. Thank you.
So actually, you probably don't have to reach out to IT industries. You could just come to IIT itself because there's a lot of work happening again, and I'm selling probably IIT a little too much. My colleagues have started giving me looks. So one of the key aspects is that I have been looking at industries having a lot of data and going from an ERP system to going to now having shop floor data on the cloud. And the best aspect about that is that you are able to go to any place and figure out as to essentially what was the history of that. So the data has become a little better than data, and it is a slightly more organized dashboard which is available at the fingertip. But there's a very, I would say, long journey which the data has to still make, because the data has to go from data to information, and information has to then go through a process of picking knowledge, and that knowledge finally has to become business, analytics, which has to finally come back. So I do not think we in India and even abroad right now are really using the data to our advantage. Data is more so just sitting in clouds, in data lakes, and is not being really utilized by the industry to the limit where they actually start getting dividends from that. So as you say, is the data working for you? Just like, is the money working for you, or is it just sitting in the bank? And that's one area where I feel IIT can play a major role, be it the deep learning image classification which you're trying to do for the scrap, or be it the process data which you have on the cloud. These aspects could have a real-time classifier based on artificial intelligence, which could really be some things which you can utilize based on your specific business objectives. And that could be something which you can apply based on what you want. But essentially, this is one very active area which I feel would have a major role in future. And that will certainly be playing a role in energy efficiency as well and environment. So coming back to the last aspect, and I want to stick to now metallurgy a little more, I would like to hear from you in terms of what are the key metallurgical, technological gaps which you feel still exist in the induction furnace industry, where a pure physical process metallurgist could actually say that I could contribute. There are young engineers sitting here who have been doing courses in metallurgy, and they would like to know as to how that is something where they can contribute. So anyone who feels that there are some specific key technological gaps, specifically in the induction furnace based processing, where you think metallurgy still has been developed, and as was rightly said, that world has not really worked a lot in this area because this is an area which is not really being used by them a lot, and this is thus something which we have to develop and do research in.
Okay. So, being an induction guy, I'm the only one to answer here. Okay. Yes, there are many gaps on process control, on quality control. To give you few examples, we have a wish list or we have a problem statements written and given to our young engineers to solve them. So we are working in 2-3 areas, whatever pocket allow us to do. But there are certain areas where definitely deeper investments are required, like in induction furnace, when you say any kind of running gas you use, it keeps on wearing, and after every heat, it has to be observed for irregular wear. So the melter has to go closer to the furnace, which is at maybe 1000 degrees centigrade, and he has to visually inspect and decide whether it is fit for run for the next batch. Now, with the image processing coming into picture, the laser sensors coming into picture, I throw an opportunity for any of you who want to work on a laser and image processing, can make a device which can scan the furnace lining or the refractory lining and compare it with the original lining and can recommend us whether this furnace is fit for next batch. This is on the very high-tech kind of solution which we are looking for. On quality side, yes, we keep struggling with a lot of casting parameter kind of issues. So there we need some sensors to be developed, some process optimizations to be done. So there also institutes can play a bigger role. It's a big gap over there. I'll tell you, 80% of the this induction furnace route manufacturers, they were not having enough knowledge to selection of equipment, especially the auxiliaries. So those roles were dependent on the equipment suppliers, so they used to suggest peripheral equipment needed to run their major equipment. But a lot of energy goes into those peripheral equipment as well. So some mechanism, some study, some documentation from the academic side will definitely help in reducing or selection of equipment, right selection of equipment at the time of commissioning. List can go on. One very interesting project my team is doing at our factory is trying to find out a method to have a benetic structure instead of matencytic structure, which is a very difficult to achieve. And theoretically we understood how to do it. Getting it done practically is at an industrial scale is a problem which we are facing. So such kind of research definitely institute can play a role into. And I think this can start with visiting induction furnace more often so that the problem statement can be ascertained and can be addressed.
I think that's an excellent idea. I would really encourage all industry partners here to essentially have such interactions. IIT Bombay has a very large pool of students who are doing masters, and this is usually a one-year master's program where they have to do 1 year of research. And there are dual degree masters who are doing BTech and MTech, and then there are those who are just doing MTech. And these projects could be very well suited for such students. So I feel that you don't have to necessarily go all out, and fund an entire research project from scratch in that sense, as long as you are able to articulate your problem and provide it at a correct time. And that timing is extremely important, because what happens is these are a one-year project, and I'm going to request my colleagues to interact more. But I think this could be a very, I would say, interesting interaction and collaboration where the students could work on specific projects. And once they reach some level of maturity, that's when you can take a call whether you really now want to fund a formal project beyond just an MTech project, because an MTech project is associated with a thesis, they will be writing thesis and things like that, but certainly the initial work could be done. So I think that could be a model to start with, and I basically invite all industrial partners and industrial colleagues here to be mindful of that we have a very good master's and dual degree program, and this could be very nice projects for them. However, you just have to make sure that you provide it at the right time, which essentially is by September, October, so that the students then sign up for that, and then otherwise if they sign up for something else, they won't be able to really take up those projects. But I'm sure those things can be worked out. So I think that's a very good possible start. And as you rightly said, the first start is that these students can actually visit. That's one thing which has been missing lately, industrial visits by students. So whenever I was able to take students to industries, they learn far more. One day at industry is far more than one whole month in a classroom. And I think it goes really a very long way. So I think that is one other thing which we have to really see how we can encourage. Now with this, I would like to probably start and ask if audience has any questions. We have been kind of asking. Yes, please. So we'll have to probably take one of those here.
Yeah, thanks a lot. It was a very nice discussion. I just want to make two comments. One is on phosphorus issue. Of course, I can tell you that indirectly IIT Bombay has contributed. I know that Swaran Bidarkar, who works in electrotherm, he has patented something on dephosphorization for induction furnace. And he was our student, he did PhD with us. That is one. Okay, so I know that to some extent there has been success as far as dephosphorization in induction furnace is concerned. The second aspect, you also mentioned about the phosphorus content in rebars. Yeah, to some extent, the Center of Excellence in Steel Technology, we are also, have a view that all these standards have been set by the West, where the temperature is much lower. They have to work at a much lower temperature. But probably having a higher phosphorus content can be more useful for tropical situations where corrosion resistance is more in demand. So hence, actually, we have done some initial work on this. We call it tropical steel. Some initial work has been done to find out, what is the effect of having more phosphorus. So probably, what you mentioned, maybe we have to do some more work and redefine our standards, which will suit our country, rather than, just, that's all information.
Any more comments, questions from the audience?
Yeah. Sorry. I was really delighted that you were listening my presentation, and you had made some observations also, and I really take your feedback positively. I had one specific question, sir. I was checking. Actually, I started my career as a safety in charge in induction furnace only. So I am also a metallurgical guy from NIT Bombay. So I had one specific question. Actually, two specific questions. First one is you talked about that quality ring, the phosphorus and sulfur. That is always a challenge, and usually the smaller units in India, it doesn't have AOD or lead refining furnaces. I think Pasne sir may be more relating within it because he belongs to the stainless steel, and that is specialty that requires more refining. So phosphorus and sulfur is definitely a challenge. And these smaller units doesn't have any fund for the R&D also, so they don't have R&D facility. And there is one fact, this is not my view, but China has banned steel making from induction furnace route in 2017. So how do you see that, what may be the future of India? Okay, this is one question. Just taking care of the time, I also sum up the second question also. Sir was also mentioning about the power consumption. So when I started as a chief in charge, my first task was to go and make such a charge that you have to reduce the, the power consumption of the induction furnace. And we had in our facility there was electric arc furnace also. There was also induction furnace. We were using induction furnace as a sampling for the scrap testing. So as you may be knowing that the DRI versus DRI and scrap ratio in India. You are mentioning that induction furnace consumes very less energy. I totally agree with that, sir. If you use a good density of scrap, okay. But when we add DRI, when we add any metallic mix, the mainly thing, the major thing, when we switch to electric arc furnace or any other technology is the power consumption only. So, and one of the prominent fact in India is that we are using sponge iron and scrap ratio, that is 70 versus 30 ratio. So we are using 70% DRI in our induction furnaces. So how do we see that this industry is going to be power rational, I must say, because we all know India is aspiring for a middle income country. Our GDP is one of the fastest in the world, and as soon as and there is major contribution of infrastructure in GDP, and as soon as our infrastructure increases, steel demand increases, and there is a direct proportion of steel industry increase also. So I will just ask, I just need your guidance in these two questions, sir. Just for a disclaimer purpose, I showed one slide that induction furnace or EF share will go down, and the blast furnace and GO capacity will increase. The rationale behind that was that if we see the visible changes in the industry, so we can see that there are a lot of capacity additions being carried out by those bigger mills. I will now say the primary and secondary, to be honest. So that JSPL and JSW, these all people are doing a good expansion. But when we see that induction furnace and EF sector, so there may be some expansion coming, but there are also a lot of plants which are inoperational or their capacity utilization is going down. So there is, whenever we see the number, there is 70 million tons, so it goes to 70, and then 5 million tons goes down, and 5 million tons addition. So it is kind of stagnant. So that was the only rationale behind that. So just two questions.
Well, yeah, thank you. So just maybe before I hand over the mic to him, so just like Professor Vishna said that phosphorus could be sometimes good because of corrosion, sulfur can also be good if you're doing machining. And being now in mechanical engineering, we do a lot of machining, and sulfur is not always bad. So it's essentially we have to redefine our end use, and we may just basically be barking at the wrong tree in that sense. So we probably have to rethink what really is our end use. But if you'd like to talk about the aspect of
Questions are directed
to you essentially, only go to induction.
Basically, two questions and one statement. I'll address the statement that induction furnaces are, the capacity addition in induction furnaces are not visible. Yes. See, that's the beauty. Now, whoever are from the economic side, the government is facing an acute problem of supply side and the inflation is going up, right? So, to address your inflation issues, you need quicker supply system. Induction furnace gives you that comfort. The turnaround time from planning to execution and commissioning is less than a year. And if you think on the blast furnace route, it is at least a 4 to 5 year cycle. Okay. So whatever you hear on expansion on blast furnace route is because if today they plan, their execution will happen 5 years down the line. While the induction furnace, you won't hear much because when the demand comes, supply is lacking, people will come in with their money and the capacity is matched. So this is another economical driven phenomena which people do not understand how the industry operates. So this is addressed to your statement. Now two questions. First is China. See, I'm not a best judge where China's policy has been derived or how they think of it. But look at when China's capacity gone up, what problems they were having. They were having best of the coke, met coke, metallurgical coke, but they were lacking iron ore. So they studied across world, and those days mines used to have piles of fines lying on their mine head. And they used to sell only the lumps, and the fines were lying in millions of tons. So those were again driven by economics. They went back, they redefined their processes, they derived pelletization, beneficiation, and they understood if they want to take a leap jump, the raw material issues can be addressed if they can use that low-grade fines to make the steel. So those days, their problems were different. And induction, as I said, came into picture for the recycling. Those days, China was not generating that kind of or that volume of scrap. So their problem statement was different. So they emphasized on going through blast furnace route because worldwide fines were available in millions and millions of tons. And the price differential were 1:10. With the lumps, the prices of the fines were 10% only. So that was a smart decision, again economically driven. So this is what I understood when I interact with people in China from the industry. And you had one more question. Can you repeat? Because yeah, okay. See, when you say power consumption on induction furnace, this is not the right measure to evaluate your footprint of consumption. So you can say electrical consumption in melting may go up with the DRI, but from iron ore to making DRI, the energy consumption is much lesser compared to what you do in blast furnace. So from iron ore to steel making, if you take the complete integration, the overall energy consumption is much lesser vis-a-vis the blast furnace. So yes, when you make a DRI, there is a lot of gangue, a lot of silica present in it. When you melt it, you waste your energy. But even if you add all the energies which you put in the form of coal, in the reduction of iron ore, or the electrical energy you put in the induction furnace, the total energy consumption is lesser compared to the blast furnace at any given point. And one thing, I would like everyone's attention to this particular observation of mine. He said when he was being appointed as a shift in charge, the sole responsibility or one of the major responsibility given was to reduce consumption by giving out appropriate charge mix, right? So no regulations were put on that industry to reduce consumption. Still, that unit has appointed a qualified engineer to see that his economies survive. He survive in the toughest competition he is facing, and industry do it by its own. Where we can play a role is definitely giving a equal level playing platform among all the producers. So in one area you have a different power rates, in another area you have a different power rates, that's a detrimental. At one end you says in your tender document, this route steel only, this is a discrimination. So their policies should play a role rather than making us aware of how to save money. We are the businessmen. We know how to save money. Thank you.
Well, thank you. We have time. Oh, we're out of time. Okay. All right. I think so. I'll hand over back to you because we're completely out of time. I thought we could probably have some more questions, but I think thank you very much, all of you, for enlightening discussion.
Mr. Vishwa Bandhu needs to leave, he needs to be somewhere else, so he would be taking our leave. I would request him to please present some concluding remarks.
So, thanks to you for patient hearing. As far as the opportunities in induction furnace are concerned, in addition, I'll give you two more points where you can work. Number one is utilization of the waste. The slag is generated, and when the scrap is melted, the generation of the slag quantity is less. But when DRI is melted in the induction furnace, there is an enormous quantity of the slag generated. And today that slag is totally waste. It becomes a headache for the steel plants. It is a disposal problem also. Today they are using the slag only for the landfilling, that's all. So it's a very big opportunity to all of you who wants to work in this field, that how we can utilize this slag for a gainful purpose, for a meaningful purpose, and generate money out of the waste, number one. Number two challenge in the induction furnace industry is that a lot of heat is wasted in cooling of the coil, induction coil. And that is a significant portion of it. Can you devise some method to capture this heat and utilize this heat? So there are two other challenges in addition to what already have been discussed. Most of us, this is very right that the induction furnace has to stay, because whatever scrap generated, see Indian economy, our mindset is what? Our mindset is that whatever equipment, whatever things we are using, white goods sector, automobile sector, whatever, we try to use it till its life ends and above that also. American industry, European industry, they use the equipment till the life is over, that's all. They will not use even one day more than that. We have the bridges 100 years old. In America, in Western countries, the designer makes the bridge and he declares the end of the life, say 30 years. A ship is made. The day it is used for the service, its date of expiry is also given. After 20 years, the ship will not be used. And the Western world don't use that ship or whatever, even a single day, more than that. And that's why the America is a country which generates the maximum quantity of the scrap. And you see the American steel industry, the steel production is almost 80% by the scrap route. But in India now, because of the ELV and all that, and the end of the life vehicles and all that, the policies is coming. Now it is certain that more and more scrap will be available in days to come. So induction furnace has to stay, not only has to stay, it has to grow. And it has to grow with a higher percentage as compared to the normal growth rate of the steel industry. Suppose we are projecting our figures of steel production at a rate of, let us say, 6% CAGR. Induction furnace industry has to grow more than that, because the scrap will be available at a rate more than that. And I told you that arc furnaces, they will not use the scrap, because arc furnaces are very flexible with respect to the raw materials. Whatever the raw materials you give to the arc furnace, that will produce the best quality of steel, no doubt about it. Because they have all the controls with them. Number 3, opportunity for you in the induction furnace is how we can minimize the melting time. See, in arc furnace you can melt the steel very quickly, because the transformer ratings are very high. In the arc furnace industry, the transformer ratings are 1:1. That means if you put a 100-ton arc furnace, your transformer is 100 MVA, 1:1. And that's why the melting rates are very fast. In induction furnaces, we are using a very old one. We have a transformer rating of 0.4 MVA per ton, and that's why the heating rates are very slow. So, you have another very big challenge in this, that can you increase the transformer capacity, say 0.6, 0.7, 0.8, and reduce the melting time? So your all economics works in favor of that. So that's all with me. Yeah. Thank you.
I would now request Siddhi to present our guest, Mr. Vishwa Bandhu sir, as with a token of gratitude for his presence and insights on the panel discussion. So before we end the panel discussion, I would also before we end the panel discussion, I would just take this opportunity to introduce our esteemed guests in the audience that are present with us. We have with us Mr. Govind Goyal, CEO of Kalika Steel with us. I would like to invite him on stage to present some few concluding remarks.
Thank you so much for inviting me to this platform and letting me share my opinion. As already discussed on this August platform, India is lagging behind in the per capita consumption, as we have already discussed. We are way behind China, which is almost standing at 400 kgs, and we are still at 75 kgs, with the population being almost the same. So there's a long way to go, and I really think that the induction furnace route, which is already contributing around 60% to the long product manufacturing, can go a long way with all the technological developments going on in the industry, like AI-based raw materials sorting to controlled melting and casting, and state-of-the-art rolling mills, mini mills. So I really think that induction furnace can be a major contributor of manufacturing steel in the coming years. So thank you very much. I really thank the department for organizing this event and letting the induction furnace manufacturers be a part of this forum and present our thoughts. Thank you so much.
Pradeep Goyal ji, the MD of Agarwal Channel Mills Private Limited from Raipur. I would like to invite him as well to present with us his concluding thoughts and remarks.
Thank you for inviting me to this platform. I'd like to thank very much Nitin especially for beautifully putting all our induction furnace about this industry, which is not very known to everyone, and all the problems, or not the problems, but the opportunities we have in terms of research and what can be done in induction furnaces. So there are a lot of opportunities which can be explored. So I request this department to make some research teams. We are open for allowing in our industries to share all the data and everything you want, and we can jointly work on something, and it would be very good for industry as a whole. So thank you very much, I request, and I'll thank you the professor for nice explaining so beautifully everything. Thank you very much everyone.
I think now we have reached the end of this really insightful panel discussion. I hope this is the start of many more such discussions to come that will make India lead in research and innovation. So I would like Siddhi to present our guests with a token of gratitude for their insights on the panel discussion. thank you, Professor Asim Tewari, sir, for your insights. Please give a huge round of applause. We further thank Mr. Nitin Kabra, sir, for his wonderful insights about the industry. We thank Mr. Panse, sir, for his insights and his knowledge